A company manufactures and sells widgets. The price-demand equation is X equals 35,000 minus 5,000p plus 0.9 times A minus 0.00003A squared, where X is the monthly quantity sold, P is the price, and A is the monthly level of advertising. Fixed costs are $15,000 per month. The per unit cost is $2.50. The current monthly advertising budget is $5,000, and we want to find the price of the widget that maximizes the company's profit, and we want to know what the maximum profit is. Okay, so this is a strange equation because we have advertising, and if we look at this for just a second, advertising comes into this where normally what happens, so normally we don't have these last two terms. Normally we just have this first and second term, and as we increase prices, the quantity we sell goes down. Here, if we increase our advertising budget up to a certain extent, as A increases, the more units we're going to sell. But again, you've got this term here with the A squared, which means that as that advertising budget increases and increases, eventually the amount of money returned on that advertising budget goes down. All right, so let's have a look here. Now we know in this example that the advertising budget is $5,000. So the reality is it doesn't matter. So if we take X equals 35,000 minus 5,000p, we simply have to add 5,000 times 0.9. So I'm going to grab a calculator and figure this out. 5,000 times 0.9, well, that's $4,500. So plus 4,500 plus 4,500 minus, let's switch back the calculator again here, and let's just do this calculation, 0.00003 times 5,000 squared. So that's 750. So we're going to subtract 750. And so we end up with, let's see, 35,000 plus 4,500 is 39,500 minus 750. So 38,750 minus 5,000p. And now we're in a world that we're pretty comfortable in. We want to find the revenue. The revenue of X is equal to X times P equals, again, I don't really care whether I solve this equation, so in fact we're going to make this R P. X times P equals 38,750 minus 5,000 P times P, parenthesis, so that's 38,750 P minus 5,000 P squared. Costs, so we want this in terms of P. We know the costs, fixed costs are 15,000, so 15,000 plus advertising, 5,000, plus 2.5 times X, so that's 20,000, plus 2.5 times X was 38,750 minus 5,000p. Okay, I'm going to calculate again. My math is okay, but I'll probably screw it up if I try to do it in my head. So 2.5 times 38,750, 96,875. So that's 96,875. So 20,000 plus 96,875 is 116,875 minus 2.5 times 5. That's going to be 12.5. 12,500p. Okay. Profit, slightly annoying that I've got P of P, but anyways, we'll just be careful, is 38,750 P minus 5,000 P squared minus 116,875 minus 12,500 P. So what do we have? We have 38,750 plus 12,500, which would be 51,250 P minus 5,000 P squared minus 116,875. Okay, so we have this function. We want to maximize. So we're going to take the derivative, find critical numbers. So P prime of P equals 51,250 minus 10,000 P. Constant disappears. Set that to 0. Equals 51,250 minus 10,000 P. And we solve for P. So P equals 5.125. So we have a critical number at $5.12.5. We should do a quick check here, which is going to be a little bit hard. But 5.125 P prime P. So we're doing a number line for the first derivative. The critical number at 5.125. We want to know whether P prime is positive or negative to the left. And nicely, P prime is a linear function, so it's pretty easy. If we're to the left, P is smaller. This is positive. P is bigger. This is negative. So it's increasing, and then it's decreasing, which means that 5.125 is a maximum. And then in order to find the maximum profit, we need to plug 5.125 back into our equation. Now, I've left out a step, which is we ought to check on the range of valid prices. So we ought to say to ourselves, go back to our price-demand equation here, and say to ourselves, what's the range of valid prices? Clearly, P could be 0. That would be the smallest price we're allowed. And clearly, there's some price which makes demand 0, and that's going to be the largest price. But again, if we think about this, well, if we choose the price which makes us sell the most stuff, choose at P equals 0, X is 38,750, well, we're not going to get any revenue because R of P is X times P, which is now 0. And we're going to get lots of cost because we're going to create 38,750 units. And so that's got to be bad. That must have a negative profit. So that can't be better. And let's think about when P is large enough so that P is the biggest it can be so that X is now 0. Well, R of P clearly is 0 because X times P, X is now 0, so this is 0. So there's no revenue coming in. And then now we're not producing anything because our price is too high, but we still have fixed costs now of $20,000. So that's got a negative profit, and so that has to be worse. So P equals 5.125 must be the maximum profit. And we plug 5.125 into our profit equation, and we will find out